Here's a PS question on inequalities. Now this is interesting. You first have a certain inequality given to you. Then you have to evaluate some statements for whichever ones must be true. Then you will come and mark the answer here once you find out which ones must be true. So I will come to the choices later on. First we need to understand everything up till here. So let's isolate this. And here you go. Now if you read, it says if this thing happens, then which of the following must be true. What that means is that this is my only given information, and based on this given information, I will evaluate each statement to see which one must be true, which one is guaranteed to be true if this yellow thing is true. Now I will be able to evaluate the statements only after I understand my if condition, because this is what I have to use as the basis further. So first we'll come down to just this and see what this tells me about x. X is the unknown here and x is what I see in each statement. So let's only focus on this much. Now this is a very simple inequality to solve. You simply isolate your x by doing some quick manipulation. First you will come to this stage that 5 is less than negative x. Now if you multiply -1 on both sides, it's gonna flip your inequality. So if I write this in a more recognizable form, then this is simply saying x is less than -5. Now to completely understand this, we will visualize this on the number line. So if this is -5, then x is everything less than it, which means x is on the left of -5, excluding -5 itself. So then this is the only given information I have. And if I come back to the structure here, I can now replace it here this way. If x is less than -5, then which of the following must be true. So this is what you will take as your only piece of given information, and this is what you will use one by one with each statement to see which statement is guaranteed according to this. So let's look at just the first statement with this given information. Perfect. Here's your given information and here's what I need to check. So I have already visualized clearly my given information. It'll be easy to analyze if I also visualize what I need to check. So the information I have is that x is on the left of -5. And what this statement here says that x is greater than 5. So if I put them here, this is what it's saying, which means if x is in the blue range, then must it be true that it's in the red range also? It's impossible. Leave aside being must be true. If it's in the blue region, it can never be in the red region. So this statement is actually a cannot be true statement. You don't have to be that specific, but it's good to understand. So it's eliminated in this race of being must be true. Similarly now, let's keep just this blue region and bring in statement 2.
Hit that like button so that other GMAT aspirants can also learn from it. And to stay tuned with such content, hit the subscribe button below. Now, to take your learning to the next level, we have put together a free trial in which you can experience content in all the sections tested on GMAT Focus Edition. For example, you can build your CR pre-thinking skills, you can learn how to approach statistics questions in graphics interpretation as part of DI, you can learn everything about linear inequalities as tested on the GMAT Focus Edition, and a lot of other content. The link for this is in the description. Now, let's get back to the question at hand.
Here we go. Again, let's first understand what the second statement is saying. The previous one was very easy to directly visualize, but this we'll have to solve. This is an absolute value inequality. You can read this in this way, that it's the distance of x from -3, which is more than 2. So where is the distance equal to 2 first of all? You go 2 to the right, you go 2 to the left, and because you want the distance to be more than 2, you go further away. This way. So I know when is it that my inequality is going to be true, this second inequality. But let me reiterate what is the question that we're trying to answer. I'll put it here for you. Look, this is what I had. That if x is less than -5, then this inequality here must be true. Now, so I'll go one level deeper into the translation. Look at this. Here, read. If x is less than -5, then the distance of x from -3 must be greater than 2. Here, I've simply rewritten my inequality in the distance notation so that I can then connect it with the final inference that I got from the distance. Let me show you that now. So, look here. This means that all of the x's that are less than -5, they should be more than 2 units away from -3. Now, is that true? Is it true that whenever my x is less than -5, it is more than 2 units away from -3? It absolutely is. Look in here. This more than 2 units away, it is true for two situations, for x less than -5 and for x greater than -1. I don't care about where all this is true. All I care about is that if x is less than -5, which is if it is here in this left region, then is it definitely more than 2 units away from -3? And this is definitely true. So this statement must be true. It is a common trap to think about this region and therefore say that it is not definitely true. That would be if you consider this side to be your given information and you try to check whether x is less than -5. That would be absolutely wrong. Observe how this layer by layer translation made it very easy for us to evaluate the statement. We were very clear about what is given, what are we checking. Simply seeing whether for these values of x, this thing is satisfied, this distance thing is satisfied. And it became all very nice and clear when all of this math turned into simple English. With this, let's go into statement 3. And here we go. So this time this is written in words. You'll first convert this into an equation, into a mathematical form. So this means -x plus 5 is greater than 0. I can simply write this as an inequality, which means x plus 5 itself is less than 0. Now, if you rearrange this, it says x is less than -5. This is exactly what my given information was, which means this time my red and blue regions are identical. So wherever my x is in the blue region, it is definitely in the red region as well, which means whenever my x satisfies this given inequality, it definitely also satisfies this third statement. So the third statement also must be true. And now it's time for us to mark our final choice. So let's look at it here. We evaluated each statement one by one and we came to the conclusion that 2 and 3 must be true. Accordingly, our choice should have 2 and 3 only, not the first one. When I do a quick scan, I see that it is choice D. Very simple to finally mark. The main thing was understanding the question.
At this point, let me ask you this. Could you have arrived at the approach of solving this question with this level of clarity had you not spent the effort in thoroughly understanding the information presented? And because this skill may not come naturally to many of you, we have created a course architecture that ensures that we teach you this skill through every guided quiz in the e-GMAT course, and we reinforce the same in every practice quiz.
In fact, the way we applied our process skills so comfortably in this question, in the e-GMAT course you will learn how to build these process skills through purpose-built exercises. With each process skill learning activity and practice quiz pair, you will find your confidence increasing. Thus, throughout the Quant course, through over 2,200 questions, you will learn such process skills so that you can also comfortably navigate even the hardest of questions.
Let's now get back to the solution at hand.
Let's summarize this now. First, we saw that there was this one piece of given information based on which we had to evaluate the statements to see which ones must be true. So we removed our choices and only focused on the structure first. Here, we identified two pieces, the given information and the information to be checked. Because everything depended on the given information, we started with it only. So this is where we picked up the given inequality and came to the conclusion that x is less than -5. This we visualized here. This was our only given piece of information. Then we kept our given in front of us and every time evaluated one statement at a time. Every time the blue region signified what was given and the red region signified what we had to check. In the first one, x being in the blue region guaranteed that it's not in the red region. It's not. That means this was a cannot be true statement and was easy to reject. Then when we came to statement number 2, this was very interesting. We saw a lot of translation here where we kept simplifying our main question. What is it that we're trying to accomplish? And as we converted our math to English, it came to a very easy format to understand that you're simply seeing for a certain range of values of x, you're simply seeing how far those x's are from a fixed value, from -3. So translation showed you how easy questions can become, how easy analysis can become, and it'll save you from falling into familiar traps. Statement 3 was really simple. Here it really, after your conversion from English to math, it came into exactly the same range as the given range. So this was a must be true statement. And then once we found all of our statements, it was just about going and marking the answer.